Well, hi, my name is Dave Bydlowski, and welcome to the Globe booth. This is one of many presentations that we're doing today on different aspects about Globe. And what I'm focusing in on is remote sensing, the use of kites for remote sensing. And we were part of a grant that was funded by NASA for 2 years. And this project is what's called the Icarus Project, investigating climate change and remote sensing. And what we really tried to focus in on are not only the content of science, but also the aspects of technology, engineering, and the application of science. Because one of the things that's happening in this next generation science standards is an important piece about technology, engineering, and science. We know that kids need to be involved in the science, understand science, but they have to be able to apply it. And they have to be looking at technology. In other words, what do they see that we need improved in our world? What do we want to do better? And then how can we engineer some sort of product to make our life better? And that's kind of how this whole process of remote sensing with kites came about. There's many things that we can observe with remote sensing. And what we try and do is, I'm going to show you how we do it with kites, but what we're really trying to do is to build a relationship to satellites so that if students can understand what they're doing here, they can get a better understanding of what's taking place in space. And in doing this, when we start making our observations, we use the protocols that come from Globe to do exactly that. There's many things that we can observe, as you know, in remote sensing from satellites, and whether it's aerosols or whether it's cloud cover, thickness of clouds, etc. There's many things that we can use satellites to help us learn about. We can do the same with kites, but do it in a much more local, place-based format. And we were working with NASA that this whole development of what are called, these are aeropods, which are part of an AeroCat system. AeroCats are airborne Earth research observation kites and tethered systems. NASA works with all kinds of different resources to do remote sensing. Well, they were using these to do work in terms of agriculture. They were flying kites, they developed this, and then started looking at how can we start making observations of our farmlands. And kites provided a very useful tool for that. So we actually came up with 3 different, and I should just go back for a second. This is Jeff Bland on the left side. He is the NASA scientist that we work with. And what was really nice about it, it was just a cold call one day. We were looking about doing something like this. We called NASA, we got a hold of Jeff. He was really excited to work with high school students. This is basically an 8th through 12th grade project that we're working with.
So how did it start with agriculture?
Agriculture, because what they were interested in, I should point out, there's 3 different types of aeropods in this AeroCat system. This one, these are video cameras, and they take video for 17 minutes, and they have an SD card in here. So after 17, we'll fly it for 17 minutes, bring it down, take the data out, put it onto our computers, and then we start going through the image processing process. And so when I take this, I can fly it up at 1,000 feet. I can observe what's on the ground, I can image process, and in Globe there's something called multi-spec software. And when you use multi-spec, it will actually tell you the kinds of things that the image is picking up based upon the light. All right? So this is what's called a monocam. This particular one is really nice because this is actually a weather station. This is a Kestrel weather station. And this collects atmospheric data. And on atmospheric data, I can set this to collect data, say, every second. And so I'll let it fly up. As soon as it's reached its highest altitude, I bring it back down. I then take a cable or a Bluetooth and just take the data off of here, put it onto an Excel or an Excel file, and I'm able to look at what are the atmospheric conditions, whether it's relative humidity, wind speed, temperature, dew point, etc. Question?
No, I was thinking about my atmosphere protocols.
So that's the Kestrel. And then this one, this is a twin cam. This is the monocam. Twin cam, obviously, because there's two cameras. And what's different about this is these are both the same video cameras, but what we've done is to remove the lens from this camera and put a near-infrared filter on it. So now what I'm doing is this is collecting visible light and this is collecting near-infrared. So now what I can do is I can actually combine images from both. So this will take 17 minutes. We bring the data down, put SD cards, and then we find matching images. So, oops, I'll give you that. So in the background, as you're watching, maybe to help understand this a little bit, we had done a workshop a year or so ago, and we took all of the resources out into the field so that you can actually see people that are going to be doing this. What they're doing in the background that Andy is showing, and my friend Andy Henry, we work on this project together at Wayne Risa. We're just outside Detroit. And what we actually do, Wayne Risa, we're a, we're a regional educational service agency. No, well we're in the same area as Wayne State, as a matter of fact. So this is our kite that we use. This is one of many kites. This actually has a 7-foot span, and we use this basically as a practice kite, although it works as well. And we also use kites that are 9 feet and 12 feet across. And the bigger the kite, the heavier the payload that we can take up with us. So what you'll see, they're setting up the kite here, they're going to be doing that. And so what I would do, just lean that here, is there's actually 225 feet of line here. There's 1,000 feet of line here. And then this is a 15-foot lead. So what happens as the kite's going up, all of this string is all wound up, and this all gets totally wound up onto the spool. And as the kite is going up, this lead will be hanging loose. And you can see that we're actually taking this lead and hooking it on top of one of those aeropods, and watch it just take off here. She lets it go. And away it goes. In other words, I'm holding my spool, all right? This would all be wound up together. I would hook this piece to the kite. This I've hooked to the kite. And as this if you could imagine this all rolled up, as the kite takes off, the string goes out, and then eventually we get to the end of this, which is connected to this piece here. I would then connect the aeropod, whichever one I want to use. I would just connect it to this, to this one here, and then away it goes. And we would start the video as soon as we release it. It will hold 17 minutes of video. As soon as that 17 minutes is done, we would then bring the kite back down, and then we would look at the data. As I mentioned here, for atmospheric data.
Do you remotely start those, or you just?
Pardon me?
Do you remotely start those?
Yeah, well, it's
Is
just
that on button?
it's just an on button. That's all you have to do. It's just like a regular camera. What you do is you actually start them at the same time. Just push a button. They both start recording at the same time. And one of the things that we do, and we have a protocol when we're looking at this, is that we're also collecting when did we launch it. We keep track of time. Before we would have even launched it, we would have taken our weather data. We would have taken wind speed, relative humidity, temperature, utilizing the globe protocols. Does this kind of make sense as to what it looks like? Let me just kind of jump forward a tiny bit. Whoops. So that you can see. This is what it looks like from the air. So the video that I was telling you about, as that's going up, the cameras are collecting the data, and that's the kind of images that we then, well, that's the video that we take out. And then what we do is when we actually do the image processing, we take stills from that. All right, we're taking individual still images and kind of matching them between from the two cameras. And what we actually did as well is we developed two apps for the iPad and the iPhone. And on those apps, you can just click onto this and you can record all of your data. So what we embedded was all of the globe protocols for the things that we wanted to test. So now if I take my iPad or my iPhone out, I can call up a particular globe protocol. I can read it if I need the field data. I can type in my data that I collect, and then I can upload that to our server. Our problem still is getting that to globe. That's what we're working on. Then we still have some issues with that. But we also are able to use, this happened to be an app here that we use. We made a nice little clinometer earlier, and we wanted to measure the height of that object. Well, what we did is we can also use our iPad not only for a field data collector, but we can use it as a clinometer app, read our degrees, and we can do other work as well. So we found that the iPad allowed us to use it as a field data collector and many apps to allow us to do different kinds of work. And these are the globe protocols that we tend to focus in on. So the land cover and the atmosphere protocols are those that are most important to the kind of work that we're doing. And we really want to get to this piece here, land cover mapping, because what happens, and I can show you an image of this. Here are some kids that are out in the field that are working on it. And there's lots of math that we can do as well. But when we are looking at our images here, like you'll see here, I'll show you one from our local site. Oh, I should also mention one thing. One of the apps that we use is something called Wind Tunnel. And a lot of times people wonder is it easy to fly a kite? These fly very easily, but they don't fly well in a city. So with this app, we're actually able to draw our area that we're flying in, kind of estimate the drawing, and then we can start the float, like put it into a wind tunnel, and we could see how much wind is available to lift that kite. So for instance here, it would be very difficult to fly our kite. So in other words, what we try and do is we have an app that simulates a wind tunnel. We can then put in our area that we're trying to fly a kite in, and we can simulate and kind of determine where is the best area to fly a kite. Does that make sense? And here is our, this is a student who wanted to come up with their own kind of aeropod. So what they did is they actually took the top of a plastic box, and those are different kinds of vernier probes that they've put in. They wanted to measure carbon dioxide temperature and relative humidity. And they also used a lab quest And so they connected this LabQuest is kind of like the computer that reads the information from the probes, and they developed this sled by itself, and in turn are flying it from the kite. So what we see students doing is, one, learning the whole process, but in turn then developing their own kinds of tools to collect atmospheric data. And this is the kind of images that we get from the camera. That's the visible light camera on the left. So what we do is when we have those videos, we stop them in light places. On the left, we see visible light. On the right, we see near infrared. And we actually tend to really just put one on top of the other. And I don't want to bore you with the whole process, but you actually remove a band. And this is what happens when you do image processing. But the part that's kind of neat with Globe is this piece here when we get to multi-spec, because the multi-spec software will tell us what is there based upon the light reflection.
I have a problem this in the mountain, but it's a shadow.
Oh, a shadow?
Okay.
Oh.
For mountain.
Uh-huh.
For classified, it's very difficult.
Yes, it is difficult. But when you do this whole classification process, this is certainly not easy to do, I don't think. But it's something that students, you'll get students who want to work on this and put that kind of time in. But what I think is also good is that what students can do is to ground truth. So for instance, we know that the multi-spec will tell us certain things are on the ground. Well, now what we want to do is to go out to that ground, make study sites, and verify and ground truth that kind of information. And that's all done through the Globe protocols. So how am I doing on time here? Pretty good? Oh, pretty good on time. So the main thing I'd kind of like to review with you is that we were part of a project that was studying climate change. And an important part was doing remote sensing. So we worked with NASA to help develop and work with these aeropods that we fly from kites. The purpose of doing that is to collect atmospheric data and to do image processing. But where it connects to Globe so perfectly is when we get to the ground truthing part, when we get to the flight management, when we're actually determining what are our conditions for a good flight, we're utilizing Globe protocols. And then what happens is students are taking this kind of concept and developing their own student projects on remote sensing, utilizing Globe protocols and the aeropod and kite system. That sound okay? Do you have any questions?
So how do you bring these down?
Well, if you can imagine, remember this whole thing. I'm holding this, all right? So you hold it, and here's how you bring it down, like this.
Oh, you just
Pull it in. It's very slow. And at 1,000 feet, what's really fun about these kites, they launch so beautifully, and they just take off. And you're at 225 feet already, and then you connect this, and then it takes off another 1,000 feet. The problem is, you have to bring it down. And so what went up so fast comes down so slow. And we use leather gloves because this could cut your hand. And you mentioned, where do you get that kind of information? That was also when we used our ground truthing and multi-spec, how complete we could get. But there's many, that's the air column profiler. That's the kind of data that it gives us. But if you are interested in that, we have a website, icarusproject.net, and I can show it to you later. But these are some of the places. This is something called PLOTS, the public laboratory. They deal with maps, they deal with kites, hot air balloons. But this is where we get most of our kites. We go to Into the Wind in Colorado. all right, and right by Globe, because that's where Into the Wind is located. And as well, there's many places for aerial imagery products. So if you're interested in this, I could certainly give you the link for this PowerPoint presentation, or if you could use that, I'd be happy to do that. Thank you for joining us, all of you for joining us here, all of you. Thank you very much. Oh, don't hold back, please. Oh, thank you. Thank you very much.